Move on here. The horizontal asymptotes of this rational function. So the horizontal asymptotes are, they go left to right. These are given, this has to do with end behavior. So the horizontal asymptote is the same as end behavior. What happens in the long run? As x goes to infinity, what happens? So there's three rules. The first rule is you look at the degree here. So we're going to call this degree n, and we're going to call this degree m. So whatever this is called degree m, this is degree n. Now if n is greater than m, that means that the top is growing a lot faster than the bottom. So this is going to shoot off to infinity. So there's no asymptote. It goes to infinity. It's unbounded. When n is equal to m, what we do is we look at we ignore everything except the leading coefficients, and we take that fraction. So it would be the fraction of the leading coefficients. It means they're both bottom and top are growing at the same time, at the same order, the same magnitude, and so we just look at that ratio. When n is less than m, that means that the bottom is growing faster, so you're dividing by a really big number. That means that y equals 0 is the asymptote. Asymptote. So what's the case here? The case here is that the degrees are even. This is the first degree, this is the first degree, so therefore, and this would be equals y. So y here equals the degree, the ratio of the leading coefficients, -3/2, and that would be it. Oops. Okay. Give the equations of any asymptotes of the type specified for this graph. So asymptotes. So we already know what a horizontal asymptote is from here. So let's think about this case. The degree here is 1. The degree here is 2. That means that this is what's going on. Y equals 0 is an asymptote. So y equals 0 is the horizontal asymptote. Okay. The vertical, actually it tells us it wants just the vertical. Should have read all the instructions. So the vertical asymptote is where undefined. And where is the function undefined at? When you're dividing by 0. So this is x squared plus 2x minus 48 equals 0. Now 48 is 8 times 6, and 8 minus 6 is 2. So this factors nicely as x plus 8, x minus 6. I'm going to check it just in case. 8 times -6 is -48. 8x minus 6x is 2x. So at x equals -8 and x equals 6, we have our vertical asymptotes. Use the graph to find the vertical asymptotes. It's right here. X equals 1, 2, 3. And that's it. Let's not overthink it. Find a horizontal asymptote. There was no dashed lines, but that's because the dashed line is actually right here along the x-axis. You can see that this function, gets closer and closer to y equals 0. This function is closer and closer to y equals 0. So y equals 0 is the asymptote. Let's not overthink that one either. The x-intercepts are where x-intercepts are it's where y equals 0 and you plug it in. These are also known as roots, zeros, the factors of the polynomial, and so on. This is where when y equals 0, when you multiply both sides by the denominator, all you're left with is this right here, the top. So when the top is 0, the whole fraction is 0, right? If this is 0, everything is 0. Well, x squared equals 49, and x equals, it's gonna thinking and writing at the same time. X equals plus or minus 7 would be our x-intercepts. Now, x-intercepts are points, so this is -7, 0, comma, 7, 0. Y is 0 on both of them. The y-intercepts are where x equals 0, right? So all I gotta do is plug in 0 here. This is gone, this is gone, this is gone. So y equals -11 over -7 equals 11 sevenths. So the y-intercept will be 0, 11 sevenths. And that would be it. Oops, okay, I erased it. There we go. Solve this inequality. Okay, now this one, not too bad. What we're going to do is we're going to look at where is this equal to 0 at? Because when it's equal to 0, we can draw a number line. And, well, let's start with that part first. This is equal to 0, just like the last problem. This is equal to 0 when the top is equal to 0, right? So all I really care about is the numerator being 0. Well, that's easy. That's going to be x equals 4 and x equals -4. -4 and 4. I draw a number line, and -4 is right here, 4 is right here. And since this includes it, it's going to include these points. But we want a region where it's less than 0. Now it could be this region, 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 plus this region, or so on. Now I'm going to show you two different ways to do this. The easiest way is to use your calculator. And this way will help us in two different ways, at least. So we graph it, and we have x minus 4, x plus 4 divided by. Now usually I would put parentheses around the numerator, but in this case PEMDAS, since there's only one thing I'm dividing by, it should be okay. So this looks, we can see here where is this less than 0? It's less than, less than 0 here. I'm gonna copy this over here. Now remember, you're allowed to use calculators on the test, so use them. This is what the function looks like. Okay, and I guess I'll just draw it again. From -4 this way, it is less than 0. It's greater than 0 here. It's less than 0 between here and 0. And then positive again. So this is negative infinity to 4, and it can include 4. Now the reason we have to, where does the 0 come from in the mathematics? 0 is where this is undefined. So what we're going to do is we have to break this up actually into another part. This is where it's actually undefined. So now there's 4 regions to worry about. Minus, plus, minus, plus. It's negative here, it's positive here, it's negative here, it's positive here. So 0 to 4, and it includes that point. Now the way to do this, what this helps you out also because it gives you a table. So if you didn't have a calculator, you would plug in test points. You might plug in -5, and the thing is, the table gives you what -5 is. Negative. So that means that's negative. Let's say we use 2 for the next region. 2, -2. -2 is positive. 2 is negative, and then we would just go to our table and we scroll down just a little bit. To 5, and 5 is positive. So everything after that's going to be positive. So you can plug those in, but this actually gives you those values too, so it saves time in 2 different ways.